Good day. Today we're going to deal with logarithm functions. So logarithm functions or exponential functions usually give students a lot of problems. So we'll deal with logarithm functions and we'll also deal with a little bit of exponential functions. So let's deal with the first type of question. So they can say write down the coordinate of C. So if they say write down the coordinate of C, it means that you don't need to calculate because it's also worth 1 mark. So if they say write down, it means that you don't need to calculate. So C is usually 1 point ahead of the vertical asymptote. That's how they do it in metric. So if you had an exponential graph, let's just say you had an exponential graph, and let's say the horizontal asymptote is y is equals to 0. If they say write down the coordinate of A, it's always going to be 1 point above the asymptote. So if the asymptote is at 0, then it means the coordinate of A will simply be at 1. So it means that you'll just say A is 0 is to 1. So it's always 1 point above the asymptote or 1 point below. For instance, you could receive an equation like this. Let's just say we've got an asymptote y is equals to -2, and let's just say we've got an exponential graph like this. So if they say write down the coordinate of D, let's say this is the coordinate of D, then it's 1 point below the asymptote. So it means it will be at -3. So it's gonna be 0 is to -3. So the asymptote, or rather the intercept, the y-intercept is always 1 point below or 1 point above. So that's the pattern. So that's what they do in metric past papers. So what about logarithm graphs? So logarithm graphs are always going to be 1 point ahead. So if the asymptote was at, if the vertical asymptote was at, let's say, y is x is equals to 1. So if the vertical asymptote was at x is equals to 1 and they ask you for the coordinate of C, let's say C is here, then it means it's going to be 1 point ahead. So it means it's going to be at 2. So it's going to be 2 is to 0. So when they say write down the coordinate, it means there's no need for calculation. So that is how it is. So the coordinate of C is just simply 0, or rather not 0, 1 is to 0, because it's 1 point ahead of the asymptote. So that's how it is. So the next question can be find the value of A, or they can say show that A is 2. So if they say find the value of A, we need to substitute. So we'll substitute. So it means the x value is 8, the y value is 3. So it means that we'll make the y value 3. So it's going to be 3, and then we're going to have log A to the power of, not to the power, rather, log 8 base A. So this is how we pronounce it. If we have something like this, for instance, we would call it log 5 base 3. So 3 is the base. So that's how we pronounce this stuff. So we have 3 is equals to log 8 base A. So now you would have to convert it to exponential graphs, exponential equation. So the mistake that most students do is to switch x and y. They did not ask for the inverse. So if you've got y is equals to log, let's say log A to the power of x, do not switch them. They did not ask for the inverse. Only if they ask for the inverse, that's when you switch them. So please do not switch them. So what you'll do is that you'll convert it to exponential equation without switching them. So generally, if you've got an exponential equation, let's say we've got C is equals to A to the power of B. The purpose of logarithm is to make the exponent the subject of the formula. So the exponent becomes the subject of the formula, and then it's very easy. The base just becomes the base. So the only thing that you have to memorize is the subject of the formula is the exponent, and the base is the base. That's all you have to memorize. Once you've got those two, then this one has got no choice but to come here. So it is very simple. So it is not hard to convert exponential to log or log back to exponential. For instance, if you have got, let's say we've got 9 is equals to 3 to the power of 2. We know that the exponent becomes the subject of the formula, and then the base becomes the base. And then this 9 has got no choice but to come here. So that's how it is. So it is not hard to convert exponential to logarithms. So now when you're converting logarithms back to exponential, you already know that the subject of the formula is the exponent, because the purpose of logarithm is to make the exponent the subject of formula. So it means this, since it's the subject of formula, it has to be the exponent. And then the base is the base. If you have memorized that, then this has got no choice but to come this side. So the answer has to be there. So then this means it's going to be 2 cubed is equals to a to the power of 3. And then it means a is equals to 2. So we have showed them that a is 2, or we have found the value of a. So that's what you do. So then it means that we can now write down the equation. So they can say hence write the equation. So we'll write it down like this. Now they can ask you to find inverse. They can ask you to find the inverse of f. So sometimes they give you the exponential graph, then they ask for the inverse, which is the logarithm graph. Sometimes they give you the logarithm graph and ask for the inverse, which is the exponential graph. So if they ask for the inverse, then it means that you'll simply get the inverse. So we know that it's going to be y is equals to this stuff. So to get the inverse, that's when we switch them. So we'll switch the places, because the inverse, x takes the place of y takes the place of x. So it's gonna be log a y. And then now we have to convert it to exponential graph, because now we want to make y the subject of the formula. So we're gonna make it y, and then okay, why did I write x already? I found why did I write a? I found the value of a. A was actually 2. So a is 2. So it means that 2 is the base, and what is the subject of the formula is the exponent. So that is how it is. So we have found the inverse, so we can now write it in the form of the inverse. So that's how it is. Then they can ask you to draw the inverse on the same set of axes. All right, so here is a trick. Whenever you've got the exponential graph, let's just say you've got the exponential graph. If you have got the equation of the exponential graph, and let's say this is going to be like this, and you don't know the shape of the inverse, what you can do is you can simply find 2 points in the original graph. Just have 2 points in the original graph. Maybe you'll have like literally any point. Maybe you can find out what will the y value be if x is minus 3. So if you substitute, you will have 1 over 8. So 1 over 8, it's going to be 0.125, I believe. So it's going to be 0.125. Okay, 0.125 is 2. Okay, why did I say 0.125? So it's minus 3 is to 0.125. So that's what you put, and then from there you can substitute any other point, literally any point. So maybe we can find what will the y value be when x is 2. So when x is 2, when you substitute, it's going to be 2 to the power of 2, which is going to be 4. So it means 2 is to 4. So then 2 is to 4. When you have got 2 points in the original equation, then you can easily determine the shape of the inverse, because all we have to do is to switch them. So when you switch them, it means that this in the inverse will become 4 is to 2, and this one in the inverse will become 0.125 is to negative 3. I'm not saying you must write it in the form of decimals. It's better to write it in fractions, but you need decimals so that you can be able to locate the point to know where it is in the graph. So where is 4 is to 2? So 4 is to 2 would be somewhere here. So that would be 4 is to 2. And then 0.125 is somewhere close to the y-axis. It's to minus 3, so it's going to be somewhere here. So 0.125 is to minus 3. Now check what will happen. This, if you join it, will have no choice but to be this shape. So basically from just 2 points, you're able to determine the shape of the graph. So what you need is 2 points in the original graph. When you've got 2 points in the original graph, you will just switch them, and then that will tell you the shape. For instance, if one point was here and the other point was here, you know that the logarithm graph will have to be like this, because the logarithm graph has 2 shapes. It has got this shape and it has got this shape. So in metric, it has to be one of those two shapes. So just by having 2 points, we're able to determine the shape of the graph. So let's deal with this part. If they ask us to draw the inverse, then we already have 2 points, so we can simply switch them. So if we switch them, we know it's going to be 3:8. So we're going to have 3:8, and we're going to have 0:1. So 3:8 is somewhere here. 3:8, because that was 8:3. So 3:8 is gonna be literally up there. So somewhere there. So we're gonna have 3:8, and then 0:1. So 0:1. So when x is 0, y is 1. So it's gonna be up there. So just from these two shapes, we can tell the shape of the exponential graph. So because the exponential graph is always either like this or like this, or it can be upside down, it can be like this or like this. So it has to be one of those 4 shapes. So it's gonna be like this. So how do we know it's gonna be like that? You have to also consider the asymptote. So in the logarithm graph, the y-axis was the asymptote. So in the exponential graph, the x-axis will be the asymptote. So when you know your asymptote and you have 2 points, you're able to tell the shape of the graph. Just before I continue, if you want to be tutored, whether it is online or physically, whether it is the situation where you're struggling in maths, or whether it is the situation where you're good in maths but want perfection, take a screenshot or save these details. Whether you're studying Cambridge, which is the UK curriculum, or whether you're studying NSC, which is the South African curriculum, or IEB, or native courses which start from N1 to N6, or any curriculum you're doing no matter which country you're at, we offer tutorials. We've got lessons and practice sessions 5 days a week. We also give you tests once a week so that we can check your improvements. Alright, so let's deal with a repeating question that bothers a lot of people. They can say for which values of x is f at x less than. So they can say less than 2. So what you would do is that we have to find where it is less than. So 2 would be somewhere here, because this is the y value, f at x is the y value. So for which values of x is the y value less than 2? So what you will do is that you'll notice that this portion is the one that is less than 2, because after this portion it becomes above 2, so it becomes greater. So you want this portion of the graph. So this portion of the graph starts from this x value and stops here. But the problem is that we do not have the coordinates, so we need to find the coordinates. So for us to deal with less than 2, we first have to find when is it equals to 2. So we'll say this is equals to 2, and then we convert it back into exponential graph. We see that this is an exponent and this is the base, so it means it's gonna be it means that it's gonna be 2. Then we're gonna have x, because this has got no choice but to be that side, because this is the exponent, this is the base. So it means that x is 4. So it means that this coordinate is actually 4:2, because the y value was 2. So we have found it. Now the question says it must be less than 2, so we want this portion of the graph. So this portion starts from 0 and it ends at 4, because the x value is 4. So because I said for which values of x, so from 0 to 4. So it means that it starts from 0, it ends at 4. So x is between. So that's how you answer the question. But what if the question says less or equals to? If it says less or equals to, then it means you would put equal signs there. But we've got a problem. We cannot put equal sign where there is an asymptote. So whenever the question has equals, you just put equals, but wherever there is an asymptote, you do not put equals to. So that is how it is. What if the question says it must be greater and not less? What if the question says f at x must be greater than 2 or greater or equals to 2? Then it means we want this portion. So this portion, where does it start? It starts from 4, but it has got no end. So it ends at infinity. This is a repeating question. It's very easy to answer this stuff. So it starts from 4 until infinity. So it means you just say x is greater than 4, greater or equals to 4. So that's all. So that's how you do it. X is greater or equals to 4. Just before I continue, if you're interested in knowing the prices of the tutorials, the video that contains the prices and the updated contact details, just in case these ones have changed, is found at the end of this video. And if you want my videos on, I've got a video that deals with f at x times g at x is greater or equals to 0. I'll put it at the end of this video. And also I've got videos on the domain and the range. Yeah, so matter of fact, I'll put the playlist of functions at the end of this video. So that is how it is. So it is easy to deal with the exponential graph. Alright, if you like the video, please like the video and subscribe to my channel.